Well, as usual, you can find the handout on the website. I'll send it around also. This is our second week talking about the structure of reason relations. So we're in the middle of the mandala of metavocabularies that I've taken as the symbol for the course. Last time, let me just remind you what the main points of the account of the structure of reason relations was. First observation, there are two flavors of reason relation: implications and incompatibilities. And I suggested it was a mistake to try and get one of them to do the work that the other one does. And second of all, pointed out that there's a substantial structural asymmetry between them, in that one kind of reason relation is de jure symmetric and the other isn't. That incompatibility is symmetric if A is incompatible with B, B is incompatible with A, whereas A can imply B without B implying A. And I at least waved my hands at Ryan Simonelli's argument from the pragmatics of giving reasons for and against claims as to why that should be true. And then the other sort of large structural point I made argued that reason relations in general, let's focus on implication in particular, are not monotonic. They are in mathematics, they are in logic, maybe they are in developed fundamental physics, but outside of that, they're just not. And we talked about a fallback position you could have, what's known as cautious monotonicity, that says you can have a good implication which is defeasible. So there are additional premises you can throw in that will defeat the implication, turn it from a good implication into one that are not. But at least you can always weaken it with its own consequences. If we have a premise set gamma and A is a consequence of it, then taking A as an additional premise, making that implied claim explicit, at least that won't lose you any consequences. We saw that there's a transitivity principle, cumulative transitivity, CT, that is the dual of cautious monotonicity, that says if you make explicit some consequence of gamma, you don't gain any consequences either. Since A was already implied by gamma, the consequences of gamma together with A are just the same as the consequences you already had with gamma. And I pointed out that if you impose both of those structural conditions in a non-monotonic setting, they have the consequence that explicitation is inconsequential. That is, the moving a claim from the right side of the turnstile to the left side of the turnstile, moving it from something that's merely implicit in the premise set, in the literal sense of being implied by it, over to the left and taking it as, acknowledging it as an explicit premise, something that you're committed to accept, that doing that neither loses implications nor gains any. And I argue that at least sometimes that isn't true, that explicitation in that sense, rational explicitation, making what's implied by your premise set, by the explicit claims you've made, making that explicit can make a difference. Sometimes you get more, sometimes you get less. Not always, but I argued there at least sometimes when we don't want to impose those conditions. Looking ahead a little, the argument is going to be, we want a logical language to make explicit reason relations. That's what I call logical expressivism, as a way of thinking about the task of logic. The job of logic is to give us conceptual tools to make explicit reason relations. And looking ahead, if there are plausibly cases where explicitation has consequences, changes what's implied by a set, we would like our logic to be expressively powerful enough to deal with that, just as we would like our logic to be expressively powerful enough to codify non-monotonic implication relations. So that's where we're going. This week, I'm going to look at some more structural principles, structure that arises in non-monotonic reason relations. First, we'll look a little bit more at implication. Then I'll say something more about implication, about incompatibility, and then at the end, a few remarks about the interactions between them. Now, just before we do that, I wanted to reiterate a point that I made last time. That's a connection between what we said in the treatment of pragmatics, in a pragmatic metavocabulary of acceptance and rejection, assertion and denial, of commitment and preclusion from entitlement on the one hand, and something that, and the notion of explicitation that was at the center of the story I was telling last time. Because both of them have a notion of implicitness in them. In the pragmatic sense, we said an implicit commitment is the sense in which being precluded from entitlement to reject or accept is being implicitly committed to accept or reject. So my version of the Restall-Ripley bilateralist understanding of implication is that we say that gamma turnstile A, gamma implies A, just in case commitment to accept all of gamma precludes entitlement to reject A. And we said, if that's so, then you're forbidden, normatively precluded, can't be entitled to reject the conclusion if you're committed to accept the premises. And I said, we can say then the only move open to you is commitment to accept that conclusion. Now, you're not explicitly committed to accept it. It's only implicit because the implication ruled out being entitled to taking the opposite stance. Now, you might still remain non-committal, committed neither to accept nor reject, but even so, your non-committal status is different once you're precluded from entitlement to reject the claim. The only one that's open to you. You still might not take it, but the only one that's open to you is the commitment. And that's a thing to mean by you're being implicitly committed to accept A. It's not the same as explicit commitment, but that's a clear notion. We've said exactly what that status is, and it's a sensible thing to mean by implicit commitments. And in the same way, if commitment to accept all of gamma precludes entitlement to accept A, that is, it rules out A, it's incompatible with A, then it implicitly commits you to reject A in that same sense of implicit commitment. All of that's in the pragmatic metavocabulary. But this talk about rational explicitation with respect to implications, this metavocabulary, this idiom for talking about implications that says we can think of what a premise set contains as having two components. What it explicitly contains is the members of the set, the premises. And what it implicitly contains is what it implies. That's the etymological origin of implicit, is what's implied. We say if gamma implies A, then A is implicitly contained in the premise set gamma. And now that's another thing, that it's another sense of implicit. Now in the metavocabulary, if we're talking about reason relations, and what I wanted to, the point I wanted to make is that those two notions of implicit go hand in hand. It's exactly what's implicit in a premise set gamma that you're implicitly committed to if you're explicitly committed to accept all of gamma. So although the two senses of implicit are different, one a pragmatic one talking about commitment and entitlement, the other just having to do with the content of a premise set as specified by an implication relation. But we should see those as two aspects of one notion of implicitness. The one expression being the pragmatic and the other the rational notion. Neither of those notions of implicitness, by contrast to explicitness, is psychological at all. And the first one is normative and pragmatic, and the second one just has to do with reason relations. And neither of them is specifically logical, because they come up for a language that doesn't have any logical vocabulary in it yet. Next week, we'll start the adventure of adding logical vocabulary to these languages. So there's notions of explicitness, of commitment on the one hand, and explicit content with respect to reason relations on the other, and corresponding notions of implicitness. So this is all rehearsing things we talked about last time, but that point I wanted to put out explicitly. Anything anybody wanted to say or ask about that? Okay. Now, when we think about the structure of implication, I said that we should think of implications in general as not being globally monotonic. If we think about all the reasons that we give, when we're giving, if we're talking about implications, we're giving reasons for accepting. When we think about all the reasons we give, often it's the case that if you throw in some more explicit premises, some of the implications drop away. You defeat some of the implications. Now, if we think about a whole structure of reason relations, what I'm going to call an MSF, a material reason relation frame. This is by analogy to a Kripke frame for interpreting modal logics. We can think of it as a triple that has a language, just some set of sentences. So far, they're all logically atomic. We can think of them as just a bunch of letters standing for the sentences. So the first element is just a set of elements. And the second is a set of good implications defined on that language. So an implication, we're still working with the more intuitive notion of single succedent implications, as implications where there's only one sentence as a conclusion. Even though the same premise set may have many conclusions, we write them one at a time. So we can think of that implication relation just as a set of ordered pairs corresponding to the ordered pair of a premise set gamma and a conclusion A that follows from it. So that's a set of ordered pairs of subsets of the language and elements of the language. Those are the ones we would mark with our snake turnstile. And we can think of the third element as being the incompatibilities. For reasons that I'll talk about later, instead of writing them just the same way we write the implications, we might want to write them, we might want to specify that third element just as a set of incoherent sets. But it doesn't really matter whether we do that or just have another set of ordered pairs of gammas and A's. Just in the second case, we include the ordered pair of gamma and A in case gamma is incompatible with A. So over any particular language, we can think of a bunch of these material reason relation frames that could be defined on that language. And when we talk about a particular implication, we're typically talking about it as an element of some one of these frames. And to deny monotonicity in general, well, a particular material frame will be not globally monotonic if it's not the case that whenever in the set of good implications you have a gamma implies A, then for any superset gamma prime, you have also as a good implication, gamma prime implies A. Or put differently, the global monotonicity claim is that whenever you have gamma implies A as a good implication, then for any set, a subset of the language delta, gamma together with delta implies A is a good implication. So a non-monotonic frame will be one where there are exceptions to that, where sometimes there's good implications and some things that you can add to them give you candidate implications that are not in the frame, that don't count as good. And the point I want to make first is even if we fix on some material reason relations frame, some set of implications and incompatibilities over a language, even if it's not globally monotonic, it may still be locally monotonic. That is, there may be particular implications. If we take a particular gamma and A, it may be the case that all the supersets of gamma also imply A. Those might be implications like if the cloth is scarlet, then it's red. The cloth being scarlet implies that the cloth is red. That implication might be hold monotonically in a particular frame, even though others, Tweety's a bird, implies Tweety flies, that's not robust under arbitrary additions of collateral premises. But maybe the swatch of cloth is scarlet, implies the swath of cloth is red. Maybe that is monotonic. If some particular implication is robust under arbitrary additions of further collateral premises, we can say it's not just the case that gamma implies A, but gamma implies A persistently. I use that instead of monotonic because we talk about monotonicity as a global property of all of the implications in the frame. But when we're looking frame by frame, we can talk about whether it's persistent or not. And the first point to realize is that we want to be able to talk about sets of reason relations, frames, where some of the implications hold persistently and others of them don't. That there's a mixed bunch of them. And there may be special properties that the persistent ones have. I'm going to write, this is on the, is point 3 on the handout. If an implication holds persistently, I'm going to write it with a little upward arrow next to the snake. And what that means is not only does gamma imply A hold, but whatever delta you add in with gamma as auxiliary hypotheses or collateral premises, A is still going to be implied by gamma plus delta. That's to say that it holds persistently. And so if in some particular set of reason relations over a language, if all the implications are persistent, that's what it means for it to be globally monotonic. But in ones that aren't globally monotonic, that have some persistent and some defeasible inferences, there's still going to be these islands of monotonicity, islands of structure where some of the implications are persistent. And so, we can think of the region that is gamma implies A plus all the supersets of gamma that imply A. That's a sort of region of persistence, a region of local monotonicity within the sea of largely non-monotonic, non-persistent implications. Persistence of an implication is a kind of necessity of it. It's saying gamma necessitates A because gamma implies A sort of no matter what. No matter what, well, no matter what other premises you throw in with it, it does. And thought of that way, restricting oneself to monotonic implication relations is restricting oneself to implication relations that hold necessarily in this persistence sense. It's ignoring implication relations that hold merely contingently. That is, not come what may, just sometimes and not others. But it would be a mistake to ignore merely contingent implication relations, it's as though if you were thinking about truth, you restricted yourself to only thinking about necessarily true claims and didn't think about contingently true claims. You wouldn't, for instance, in that case, have room for a notion of truth conditions. What other sentences need to be true for this one to be true? If you've only got things that are necessarily true, a notion of truth conditions doesn't apply. What corresponds to that notion of truth conditions is the contingently implied, the implications that only hold contingently, each of which comes with what we can call a range of subjunctive robustness. So if gamma implies A, but defeasibly, we can think about all the deltas such that gamma together with delta still implies A. All of the conditions under which that implication is robust. And that's going to be a representation, that representation of a range of subjunctive robustness for an implication. The set of additional premises that you can throw in along with gamma without defeating the implication. That's going to represent an important part of the content of that implication and of the concepts involved in it. So, if I say, well, the hungry lioness noticing the wounded gazelle implies that she will chase it. Now, that's defeasible because the hungry lioness notices the wounded gazelle, and the hungry lioness is immediately struck by lightning. From those two claims, it doesn't follow that the lioness is going to chase the gazelle. It's defeasible. And if we think about that, we see there's lots of other ways it could go wrong as well, other things that could interfere with her chasing it. But understanding that claim, understanding that implication, involves understanding that, for instance, if you add the claim "and it's on Tuesday," that isn't going to defeat the implication. Or if you say "and 2 continents away, a student is congratulated for solving an arithmetic problem." So, well, that isn't going to undercut it either. Those all fall within the range of subjunctive robustness of the implication. You can add claims about what day of the week it is or what the weather is in some distant place, and they're not going to affect this. Whereas some claims about the lioness, the gazelle, and the local situation could interfere with it. I'm saying that just as if one restricts oneself to only looking at necessarily true claims, there isn't room for a notion of truth conditions as what you understand or grasp when you understand a claim. So if you restrict yourself to only implications that hold necessarily, you're not going to have room for the notion of ranges of subjunctive robustness, which corresponds for implications to the notion of truth conditions for sentences. I mean, I haven't entitled myself to that analogy. That's sort of where we're going. Now, one of the things that we're going to ask of an expressively adequate logic is not just that it codify implications and incompatibilities. That is, let us say that gamma is incompatible with A or gamma implies A, but also that it let us make explicit structural features of particular reason relation frames, particular sets of reason relations. And I've just said that one of the striking structural features of the contour of a set of reason relations is that some of the implications are persistent and others aren't. And by the way, we can talk about persistent incompatibilities as well. You know, if gamma is incompatible with A, to say that gamma is persistently incompatible with A is to say whatever else you add to gamma, it's not going to cure the incompatibility. It's still going to be incompatible. You know, being if the object I'm thinking of is a prime number, its being a prime number is incompatible with its being a piece of music. And it doesn't matter what else is true of that prime number or what else there is, it's still going to be incompatible with that object, which is a prime number, being identical to any piece of music. So one of the features of, as it were, the shape of reason relations that is of some significance in the non-monotonic setting is local regions of monotonicity. That is the distinction between persistent and non-persistent reason relations. So ideally, we'd like to be able to express that and talk about those, the difference between persistent and non-persistent ones. And one way we could do that is to introduce a modal operator and say that if gamma persistently implies A, it doesn't just imply A, it implies box A. Then a globally monotonic set of reason relations would be working only with necessitated claims. No ordinary unboxed, unnecessitated claims would be represented. And we know that that's expressively impoverished relative to a language that can express claims with and without the necessity box in front of them. It's a remarkable feature of Dan Kaplan's logic that we'll introduce starting next week, that you can introduce operators to mark regions of local structure within sets of reason relations. So you can introduce a monotonicity box that says that certain implications hold necessarily, that is, with universal ranges of subjunctive robustness. Okay, next point, once we've got this notion of persistent implications, the ones where you can add arbitrary collateral premises without defeating the implication, what we would mark with the upward arrow to mark what's special about those implications. This brings into view more sorts of structure than we could see before. For instance, besides having local regions of monotonicity, we can have local regions of cautious monotonicity. Even if it's not true that for every implication, if gamma implies A and gamma implies B, that therefore gamma together with A implies B, that's cautious monotonicity. The idea is, well, gamma already gives you A. So if gamma implies B, then gamma together with A that it implies ought to imply B. That's cautious monotonicity. Well, we can mark where some implications satisfy cautious monotonicity. For this particular one, for this particular gamma and A, although it's defeasible that there are some additional premises that you can add to gamma to defeat it, it happens that none of them are consequences of gamma, that all the consequences of gamma you can throw in as additional premises and not defeat the implication. Again, that's what traditional logic assumes is true of all of them. But when we say, well, we want to relax that global condition, that doesn't mean we have to deny that it isn't often the case that among the defeasors of an implication, you won't find anything that that very premise set implies. We could allow most implications are cautiously monotonic in that they're robust under the addition of consequences as further premises. Again, that's a bit of local structure that some regions around gamma implies A, some for particular gamma and A, you find a cluster of other implications that are gamma plus B, or gamma plus B plus C, where B and C are implications of gamma, and they still imply A. Regions where cautious monotonicity still holds. But when we think about persistence, we see there's another pair of conditions besides CM and CT. Remember, CM says explicitation never loses you any consequences, and CT says explicitation never gains you any new consequences. We say, well, we want to deny those global principles. That's what I called reason relations that were not just non-monotonic, but were hyper non-monotonic. It's not just that MO, monotonicity, fails, CM fails as well, and CT fails. But there's a weaker condition even than cautious monotonicity. Cautious monotonicity says nothing that's implied by gamma is a defeater of gamma's implication of A. But we could be more demanding than that. We could say, well, there are some consequences of gamma that can defeat gamma implies A, but none of its persistent consequences do. And only some of its consequences are persistent under arbitrary additions. If we have gamma implies A, not persistently, but gamma implies B persistently, that is, no matter what you add to it, well, in particular, you could add A to it. sorry, it doesn't matter that you could add A to it. If it's the case that although some consequences of gamma could defeat gamma's implication of A, nothing that gamma persistently implies could do that, then we could say it was weakly cautiously monotonic, WCM. This is number 4 on the handout. WCM and WCT look just like CM and CT, except the consequence that we worry about has to be a persistent consequence. That's going to give us a weaker notion. CM is already weaker than MO, and WCM is weaker than that still. And now we're saying, well, we're mixing some implications that you can weaken with anything, persistent ones, with ones that you can weaken with any consequence, but maybe not, things that aren't consequences. And then we've got implications that you can weaken with any persistent consequences, but maybe if you weaken them with some of the consequences that aren't persistent, those are defeaters. We have a hierarchy of stronger and weaker structural principles in implication. And if we think about metavocabularies that let us describe these structures of implication and, as we'll see, incompatibility, these are significant features. What islands of or regions of a reason relation frame are there that satisfy WCM but not CM or MO? And which ones satisfy CM, therefore WCM, but still not MO? And which ones are persistent, that is, satisfy MO, but only locally? So we can see there's a lot of structure to reason relations, which we can describe in the metavocabulary I've been putting in place that has our turnstile, the pound sign indicating incompatibility, and has structural principles, not just CO, but CM, CT, WCM, WCT. And corresponding to these new structural principles, weak cautious monotonicity and weak cumulative transitivity, are different notions of implicit and explicit content, rationally implicit and explicit content. And this is what we see next on the handout. Now, I don't know whether this sort of picture is helpful at all, but let me walk through it. Remember CO. CO was containment. In Tarski's account of the notion of consequence, he says X is always a subset of the consequences of X. Whatever's explicitly a premise is implied by that set of premises. Explicit content is part of implicit content. Whatever else may be implied, the premises you've taken as your explicit content, they're implied. So any element of gamma is going to be implied by gamma. So the explicit content in red is a subset of the implicit content in blue. Well, but now we also have persistent implications, implications that are good no matter what additional premises you throw in. So gamma, maybe it doesn't persistently imply A, but it does persistently imply B. Then B is part of its persistent implicit content, and A isn't. A is still part of its implicit content, it's implied, but it's not part of its persistent implicit content because gamma doesn't persistently imply it. Within each, for each premise set, we can think about its explicit content, that's just its members, and then what's persistently implicit in it, what does it persistently imply, and then what does it just imply? Now, if it persistently implies it, it implies it. So the persistent implicit content is going to be contained in the implicit content. So that's what sort of containment principles tell us about the rational content of premise sets. Monotonicity says everything that's implied is persistently implied. If gamma implies A, then gamma together with any delta implies A. So monotonicity is just the structural principle that identifies persistent implicit content and implicit content. It says there isn't anything that's implicit that isn't persistently implicit because there are no non-persistent implications. That's global monotonicity. So if we add that to containment, we have some explicit content, and there's also some implicit content, but that's the same as the persistent implicit content. Now, moving down in the picture a little, CM, cautious monotonicity, says among the things that are implied by any premise set is what's ever implied by it plus some of its implicit content. That is, CM is saying if you make explicit what's implicit, you don't lose any implicit content. And CT, the converse, says that the implicit content of explicitations of implicit contents, that is what's implied by the premise set you get by making explicit some of the implicit content, that's always already implied. So CM plus CT says that explicitation is inconsequential. It says that implicit content is just the same as the implicit content of premise sets that are the explicitation of implicit contents. And WCM and WCT, I put them sort of parallel to CM and CT, say just the same thing, but only about the implicit content of explicitations of persistently implicit contents. So what we have here is a visual representation of the metavocabulary for talking about reason relations that I've been putting on the table last time and this time. Any questions or comments about this diagram? With the screen shared, I can't see all of you. So you'll need to say something. Okay. Now, you might well wonder, okay, so what? You can make all these distinctions. I mean, I'm trying to give you a sense of how rich the structure of reason relations is if we give up the straitjacket of closure, if we drop the very demanding global structural constraints of monotonicity and transitivity. Here's one consequence of that. And now we go right to the beginning of the handout, actually. Suppose we have some reasons for A and some reasons against A. So in a particular set of reason relations, in a particular reason relations frame, gamma implies A, that's a good implication. But delta is incompatible with A, that's another one. So gamma gives you reasons for A, and delta gives you reasons against A. That's the kind of situation we want to be able to talk about. Now, if implication and incompatibility are globally monotonic, that's to say that if there's an implication, it's a persistent implication. If there's an incompatibility, it's a persistent incompatibility. It's incurable by you throwing more premises in. Then in that context, from gamma implies A, we can get gamma together with any delta implies A. But we have deltas incompatible with A. If incompatibility is persistent, we can get from gamma together with delta, that's incompatible with A. Given the pragmatic significance of this, the first would say gamma together with delta is a reason for A, and the second would say gamma together with delta is a reason against A. All right, that's not doing justice to the collision of a reason for and a reason against. Something like the standard way of approaching that is to say, well, you're leaving out a crucial kind of structure here because you haven't talked about the strength of these reasons. You haven't talked about how good a reason gamma is for A and how good a reason delta is against A. This is where we need to bring in probabilities or credences or talk about strengths of reasons or something like that. I think that's the way we typically think about the collision of reasons here. Notice that this framework offers another way of thinking about it. It says, look in the frame of reason relations you're working with and see what actually follows from gamma and delta. Read down in the reason relation in the second element of the frame and see what gamma and delta together are reasons for. I mean, it may be that in the context of delta, gamma isn't a reason for A anymore. Or it might be that delta isn't a defeater, that although delta by itself is incompatible with A, that when we combine it with gamma, it's not. I mean, I'm saying consult the reason relations. That doesn't help us solve a particular problem, but it's an important reconceptualization of it. What you're trying to represent by assigning strengths or probabilities to implications, what you're trying to do using rankings, let's say partial orderings or total orderings of according to strength, what you're trying to do is represent this complicated topography of the reason relations. What you really want to know is, does A follow from gamma together with delta, or is it incompatible with it? That's the question you're asking. And that's a very different way of thinking about this situation than thinking about weighing strengths of reasons. And there are good reasons not to use that idiom of strengths of reasons. But what is in common is, you say there's a world of reasoning beyond what in jurisprudential terms are dispositive reasons. A dispositive reason in a courtroom is, look, if you can establish gamma, then you've settled the day. There's no more argument about it. It's a dispositive reason. But most reasons are just probative. They give you some reason, it's some evidence for it, but it might be outweighed by other reasons. They're pro tanto reasons or prima facie reasons. Let's say the jurisprudential term is they're probative. They have some rational bearing on the question, provide some evidence, but not dispositive, not enough to settle the issue. Should we think about probative reasons in terms of the topography of reason relations, where we're thinking of, rather than weighing gamma as a reason for A and delta as a reason against A, and saying, well, which is the better reason? Rather than thinking about probative reasons than that, we think, well, what you're doing is amalgamating the premise sets and asking what follows from gamma together with delta. And that takes you to a different region of the material reason frame, reason relations frame. And of course, it may be hard to find out what's there, but that's the question you're asking. Now, why might you not like the hydraulic imagery of, well, which pushes harder, say, or of weighing or assessing the strength or the power of reasons? Well, one person who strenuously objects to talking about reasons that way is John McDowell. He thinks we're misled if we're asking, as for instance, Philippa Foot does, well, what is it that makes moral reasons overriding? Isn't that a peculiar feature to think that they have such a great weight that no amount of prudential or instrumental reasons could add up to the same weight as a moral reason? Are moral reasons really overriding? Does it make sense to say that? Why couldn't there be weak moral reasons that can be outweighed by substantial prudential reasons? And McDowell's claim is, for Philippa Foot to be in a position so much as to raise that question shows she's gotten off on the wrong foot to begin with, that she's working in a bad conceptual framework. You have to be able to think of moral reasons not as weightier than other reasons for action now in the practical case. You have to be able to explain moral reasons as silencing all other considerations. The other considerations simply don't speak in concert with moral reasons. I'm talking about John's article on categorical versus hypothetical imperatives. Right? So Kantian categorical imperatives, he's saying, are not just overriding every hypothetical imperative. The Kantian categorical imperative silences the hypothetical imperatives. Now, I'm not arguing one way or another on this, though, spoiler alert, John is always right when he says something like this. But I'm not arguing for this, just pointing to that as an example where you wouldn't want to just assume that you can talk about collisions of reasons or combinations of reasons or competition between reasons on a hydraulic model. And our notion of a topography of reason relations gives us another way to think about it. Okay. The picture that I've been given, is epitomized at the top of page 3 of the handout. I got everybody to have that. Closure structure. The Tarskian topological says rational consequence is a topological closure operator, which means it satisfies monotonicity and transitivity in the strongest possible way. That's at the top level here. And at the bottom of page 2, I've given the standard transitivity notion, which is actually stronger than the CT. I didn't introduce it before. It's mixed cut. Mixed because it's mixed context cut. It says if gamma together with A, if gamma implies A and delta together with A implies B, then since all delta needs to get you B is A, and gamma gives you A, if you combine gamma and delta, you get B. And that's called cut. This was Genson's way of talking about it here, because you've used the fact that gamma implies A to cut A out of the second premise to get the conclusion. Gamma is sufficient for A. A is all delta needs to get B, so gamma together with delta should give you B. That's the mixed context, because the one implication, its context is gamma, the other one, its context is delta, and you've mixed them in getting the conclusion. That's the strong transitivity principle. There's a lot of structure in the transitivity. I only a couple of days ago put in the recommended reading Dave Ripley's article on transitivity principles. There you can look at the real deal. But anyway, mixed cut is stronger than CT. If we look at CT, it's shared context. We've got the same thing that implies A is what together with A implies B. And that's a weaker principle. You get mixed cut if you say, oh, this doesn't have to be just the same context. I'm going to go on to want to talk about the interaction of weaker monotonicity principles with transitivity principles. And one of the drawbacks of Ripley's otherwise comprehensive discussion of transitivity principles is he assumes monotonicity, full monotonicity throughout. So he doesn't look at the interaction of monotonicity and transitivity, which is what I want to do, at least gesture at. So look, those MO and mixed context cut, those are the strongest monotonicity and transitivity principles. Those give you a topological closure operator. In fact, you can get Tarski's closure operator with MO and CT also. If you've got MO, you can mix contexts. That's what it does for you. So in the context of MO, CT is enough to get the full closure structure. But if you fall away to CM, CM and CT do not give you the full closure structure. They give you this weaker analog of it that says rational explicitation is inconsequential. And I wanted to say, no, we shouldn't have that either. So just this class, I've introduced the weak. Okay, so we can think of cautious monotonicity and cautious transitivity as implication restricted principles. They say you can weaken with implications or cut on implications, as opposed to weakening with anything and cutting on anything. And the persistence restricted, these WCM and WCT, say you can weaken with persistent consequences or cut on persistent consequences. And if we restrict ourselves just to members of the premise set, then you get CO. It says that implication of explicit contents is persistent, and the transitivity principle that goes with that is contraction that says that if gamma A and A imply B, then gamma together with A implies B. I wouldn't put that in, except we're mostly not going to worry about contraction. We're working with sets, but some people do worry about it. In particular, Jean-Yves Girard, a brilliant mathematical logician, the originator of linear logic, who treats implication in terms of resources on the left, giving you things on the right. It's been very important in computer science, and he denies contraction. And indeed, in characteristic grumpy fashion, he says, anyone who asserts contraction, that having two copies of A is just the same as having one copy of A as a premise, anyone who affirms contraction, I'll give him two kicks, not two copies of one kick, but two separate kicks, and it's not the same. Okay, but I'm not going anywhere with that. What I do want to do is look at the general principle that in the interaction of these things, we've got the two halves of the closure principle, monotonicity and transitivity. And transitivity principles can drive you up the hierarchy of monotonicity. So for instance, if you have mixed cut at the top of the transitivity principles, that together with the very weakest monotonicity principle, CO, implies full monotonicity. Because mixed cut lets you mix contexts, it turns out, combine that with CO and you get full monotonicity. And this is an argument I learned from Dan Kaplan. He made this argument. Suppose gamma implies A, pick some element C, it doesn't matter which, of gamma. Then gamma together with C implies A, because gamma together with C is just gamma. We're not worried about contraction, remember? And we get any delta together with C implies C by CO, by containment. So we've got gamma together with C implies A, and delta together with C implies C. So we can cut C from the premise side of gamma together with C implies A, because C is the conclusion of delta together with C implies C, CO. So we're going to cut C as we cut A here. And we get the conclusion, we mix what's left over, and we get gamma together with delta together with C implies A. Now, our hypothesis was that C is in gamma, so it follows that gamma together with delta implies A. But then we've gone from gamma implies A, that was our supposition, to gamma together with delta implies A, using only CO and mixed cut. What we've gotten to, if you can go from gamma implies A to gamma together with delta implies A, that's monotonicity. So that very strong transitivity principle is enough to lift the very weakest monotonicity principle all the way up to full monotonicity. So there's an interaction of these structural principles. I hope that's clear enough. I mean, I have to stare at proofs like this sort of in a cool twilight hour. So if it doesn't, if you don't see it immediately, see if you can't see it when you sit down with it. But something, now I don't know whether that's a surprising result. It's telling us that these two sides of closure interact. But there's an even stronger interaction, and that is that even CT is a strong enough transitivity principle in the context of CO to lift CO containment up to full monotonicity. Well, not all by itself. We need to add a little bit of other stuff, but I still think it's instructive to see this result. And this is an argument of Ulf Flobel. He makes it in that article that's in the recommended reading or in the supplementary reading, his shopper's guide to non-monotonic logics, which I recommend you're looking at. All we need to add to CO and the weaker transitivity principle of CT to get MO is a conditional that satisfies this deduction detachment principle. Now, this is getting a little bit ahead of ourselves. We're going to look at this next week, introducing logical vocabulary, but here's an, I hope, tantalizing taste of going forward. So if gamma together with A implies B, we're going to say that gamma implies the conditional if A then B, and vice versa. This is what it is for the conditional to codify the turnstile, to let us say in a sentence, a conditional in the logically extended language, that in the context gamma, you can get from A to B. A implies B. So it's a deduction, usually deduction theorem, that if you can derive B from gamma together with A, then you can derive A arrow B from gamma. And going the other way, this is just detachment. If you have A arrow B and you have A, then you get B. I will argue that satisfying this principle is what it is to be a conditional in logic, because that's what it takes to codify the turnstile. Anyway, Ulf shows that if you add that expressive power to the language, if you add a rule to that effect, then you can derive monotonicity from CT and CO. Because we can argue gamma together with A and B implies A by CO. So gamma together with A implies B arrow A using the DD principle right to left. Now, suppose gamma implies A, that's our supposition. Then gamma implies B arrow A. We get that from this by CT cutting on A, because we assumed gamma implies A. We've got gamma together with A gives us this. CT lets us cut the A and get gamma implies B arrow A. And so using the DD principle in the other direction, we get gamma together with B implies A, but we only assumed gamma implies A, and we derived gamma together with any arbitrary B implies A. That's monotonicity. To get delta, we may need to do this multiple times for every element of delta, but there it is. So I want to again show you this argument that it's not just that with the strongest transitivity principle and CO, we can force CO all the way up to full monotonicity, but even with an otherwise plausible weaker version, the shared cut version of transitivity, even that together with CO forces monotonicity, well, if we have the expressive resources of a conditional. That's to say that you couldn't introduce a conditional satisfying this, this principle into a frame of reason relations, a space of reason relations that satisfies CO and CT without forcing monotonicity on it. Okay, the others we don't sort of know about. As I say, this is the interaction, and Ripley doesn't talk about this because he assumes monotonicity throughout. Okay, last thing I want to say again, what difference does this make philosophically? I mean, I trust you can see the sort of intrinsic, oh yeah, we can lay down these conditions and then we can see that there's potentially interesting relations among them. But we're supposed to get used to reasoning now, thinking about what it's like not to be in a rational space where consequence is a closure operator. That is, where we don't have strong enough monotonicity and transitivity principles to give us a closure operator. And here's a consequence. There are lots of places in philosophy where we talk about rationally closing your beliefs. That is, believing all the consequences of your beliefs, or at least being committed to whatever follows from all the things you are explicitly committed to. Remember, Harman argues when he's thinking about the relation between inferring and implying between the activity and the reason relation. And when Macfarlane is worried about the normative significance of consequence relations, is it a reasonable constraint on rationality that you should believe all the consequences of your beliefs? Maybe just the logical consequences of them? Well, but there's an infinite number of them. That's for belief. That seems like it's asking too much. That might be a reason why you prefer commitment. Are you committed to the rational consequences, to all the rational consequences of your commitments? Yes, well, then you have to find out what they are. So people are worried is, how are we to think about this obligation? In philosophy of science, add a new theory, and we say, well, you don't just add the theory, you add all of its consequences. It's not just the theory, it's the rational closure of the theory, where you've added to it all the consequences of it. That's what interacts with whatever other theories we're putting it together with. So people have argued, is that a plausible constraint on rationality or not? A consequence of the line of thought I've been pursuing is that notion of the rational closure of your beliefs, what it is to believe everything that follows from what you believe, that doesn't make any sense. If there are implications that are not persistent, if reason is substructural relative to the Tarski closure conditions, even if it's only taking us down to CM and CT, then there is no unique set of consequences of any given premise set. You can look in the frame in any particular frame of reason relations and say, well, if what I believe is gamma, tell me, let's collect all of the A's such that gamma implies A. And there will be a set of those. But if you make those explicit, if you add those to gamma, and you get some, so suppose that set is delta. Delta consists of every A such that gamma implies A is in the set of implications. So now we've got gamma plus delta, and now we say, well, what follows from that? You may get new stuff. You haven't gotten all the consequences of your beliefs. It's not the case that the consequences of X are always just the same as the consequences of X. That's a closure condition of Tarski. You need strong transitivity and monotonicity principles to get that. So you could add all those consequences in, and when you look at what the consequences of that is, you get new stuff. Furthermore, if instead of doing that, you just take some of the consequences. So I take a smaller delta. It's not all the consequences of gamma. It's just some of them. And I add those to gamma. And now ask, what are the consequences of those? Well, it may be that some things that are consequences of gamma aren't consequences of gamma together with this set of its consequences. You lose some things. That is, what happens if you drop the closure structure requirement, if you open up the structure and allow these open reason relations, is explicitation becomes path dependent. What follows from what you started with, the premise set you started with, in the sense of where you can get to by looking at what is implied and moving and acknowledging that explicitly as a consequence, and then looking at what's implied now, depends on which of the consequences you pick. And there isn't even anything privileged about picking all of them. That's just one path that you can take. And there's no guaranteed fixed in advance endpoint that you'll get to. It depends on the particular topography of the reason relation space that you're working with. Now, the technical term for path dependence in natural science or biology is hysteresis. That just means path dependence. And as soon as you dip below the full rigid closure structure of reason relations, rational explicitation, the process of reasoning, thought of as drawing consequences, drawing conclusions that follow from the things you explicitly accept. And when you see that this is a consequence, explicitly accepting it, that becomes a path-dependent process. It matters what order you do it in. It matters whether you do it more than one at a time. And you'll get to completely different places in general, depending on how you do that. That's why reason has a history. That's why discursive beings, which I argued is ones who make claims and defend and challenge them according to reason relations like this, are necessarily historical creatures. Even if we were perfectly rational in that we always were right about what followed from the commitments we've acknowledged according to some set of reason relations. And whenever we noticed a consequence, we explicitly embraced it. Even so, where we could get to depends on contingencies of the order in which we do that. And there's no jumping ahead, because if you explicitate a whole bunch of stuff at once, that's just one path like the others. There's nothing privileged about it. So this, I claim, is a substantial philosophical conclusion that one can draw, that is going to have reverberations throughout epistemology, to be sure, philosophy of mind, philosophy of science. If you say, look, in general, the idea of closing a theory under consequence, or a set of beliefs under consequence, isn't even intelligible unless you make these incredibly strong structural assumptions about reasons, assumptions that are so strong that they're not right, they don't hold outside of mathematics. Okay, that's the conclusion I wanted to come to. I have the sense, I want you to know that I'm aware that when I make an argument like this, I'm in danger of appearing like this. You know, it's a meme. Yeah, I have the diagrams, I have the charts. I'm aware of this danger. Nonetheless, I want to claim there really is something to be learned here. Okay, why don't we take 15 minutes? When we come back, be open for questions, and I have a few more things to say about the interaction of these different reason relations. Okay, are there comments or questions about that rant or about that material? All of that is conducted in a metavocabulary of reason relations, which, remember, we saw how to understand as related to pragmatic metavocabularies, both in that we can understand reason relations we can understand reason relations in terms of, in terms we can state in the pragmatic metavocabulary, gamma implies A in case commitment to accept all of gamma precludes entitlement to reject A, and so on. And that we could then see how to characterize the normative role that reason relations play in discursive practices, giving reasons for and against. And I've been talking about the rich structure that we find in reason relations once we open up the structure, once we admit that we want to talk about reason relations that don't satisfy the very strict Tarski-Gensen criteria. Anything anybody wanted to? Okay, well, I want to make a couple further remarks about incompatibility and then say something more about the interaction of these two. Next week, as I mentioned before, we're going to look at logic and logical vocabulary as a means of codifying, of making explicit in the language we're talking about the very reason relations that govern it. That's the way I'll understand the task of logic. First thing I want to talk about is the relation between incompatibility and incoherence. We can go back and forth between these two different notions. What's incoherent is a set. And if a set is incoherent, then if you pluck any bit out of it, that bit's incompatible with the rest of it. And we can represent incompatibility relations by incoherence properties of sets. Doing that builds in symmetry of incompatibility. Because if what you mean by saying gamma together with A is incompatible with B is that gamma together with A and B form an incoherent set, then if gamma together with B is incompatible with A, gamma together with A will be incompatible with B. What's doing the work is the incoherence of the whole set, gamma together with A and B. There are some niceties, though, that I think it's worth making explicit. Incompatibility, material incompatibility, the notion in terms of which we will ultimately understand logical inconsistency, because we'll understand negation in terms of incompatibility. That's negation on the Australian plan, as I mentioned before. Material incompatibility is just Aristotelian contrariety. Where Aristotelian contradictories are properties like red and not red, contraries are properties like red and green, as long as something can't be both of them, or circular and square. But Aristotelian contraries only come in pairs, or at least that's the way he thinks about them, even though there's whole families of them. Sort of all the colors are contraries of each other at the same level. All the shapes are contraries of each other. But what Aristotelian logic did not think about is that there can be irreducibly triadic incoherences or incompatibilities. So Sellers starts off Empiricism and the Philosophy of Mind with what he calls an inconsistent triad. Well, he says inconsistent, but incoherent. Three things that are incompatible, well, in the sense that any two of them are incompatible with the other, but any two of them are compatible with each other. So the ones he starts off with, this is on the handout at the top of page 4. And here the details of this. Well, it's hard for me to say they don't matter. This is a hugely important argument of Sellers, but that the tradition had believed all three of these things. S senses red sense content X entails S non-inferentially believes or even knows that X is red. That just by having a certain experience, you count as knowing something. You at least know what it's like. And B, the ability to sense contents is not acquired. You don't have to have, for instance, learned a language in order to do that. But C, the capacity to have classificatory beliefs of the form X is F is acquired. You do need to have learned to use the term F and learn to classify and so on to do that. And he points out that though any two of these are compatible, the three of them are not. That they can't all be, all three of them be true. Okay. Lots of philosophy, epistemology and philosophy of mind, well, it is empiricism and the philosophy of mind, that he starts off with this. Sellers loves inconsistent triads, is what he calls them. A simpler one, less philosophically fraught, is the next example on the handout. A is a blackberry, A is red, and A is ripe. Blackberries are not ripe when they're red, they turn black when they're ripe. When they're unripe, they're red. Well, red and ripe, those two are compatible because raspberries are red when they're ripe. Red and blackberry, that's compatible because unripe blackberries are red. Blackberry and ripe, that's compatible. It'll be black. Any two of those are compatible, not all three of them. Let's see. Unripe blackberries are red. The children say blackberries are red when they're green. Green meaning unripe. Anyway, there can be these irreducibly triadic incoherences. And when you see that, you see there can be irreducible foursomes that are incompatible, where any triad of them are compatible. Indeed, using logical vocabulary, we can generate these conditionals and negations. We can generate sets of arbitrary size where the whole thing is incoherent, but any subset of it is coherent. I can't resist mentioning, while I'm in the vicinity, Sellers thought this feature was specific to concepts, and that so it would be true of classificatory beliefs that they can stand in these irreducibly triadic, let's just talk about that, but that it was really controversial whether percepts could. And what's come to be known as Sellers' challenge, which is known among chefs who don't know who Wilfrid Sellers is. They just have heard of this as Sellers' challenge. This was part of his table talk, is to come up with 3 foods such that any 2 of them go well together, but all 3 of them don't. Setting your standard of what goes well together anywhere you like. If it's more demanding, well, then the pairs have to be good together at that standard, and the triad has to not be. Just 10 years ago, we had a Sellers conference in Dublin on the occasion of the 100th anniversary of Sellers' birth in he was born in 1912. We had this in 2012, and John McDowell used his $1 million plus Mellon Award to fund this conference. And one of the challenges there was the Sellers Challenge. And I'll just report that the best solution to it that we came up with at that conference, and you'll probably figure out where people came up with it, had not to do with food, but with drink. And it was beer, whiskey, and lemonade, where the claim was, well, beer and whiskey is a Boilermaker, and people voluntarily drink those. Whiskey and lemonade is a whiskey sour, and people drink those. Lemonade and beer is a shandy, people drink those, but you really would not want to drink the mixture of all of them. And I will report that the barkeep in the bar in London where we were investigating this was happy with mixing Jameson's whiskey with Guinness Stout, was happy mixing either of them with lemonade, and flatly refused to mix the three of them. For us to test it, we had to order the lemonade separately and mix it ourselves, because he said, gentlemen, there's some things I just won't do. So at least his view was this was an actual instance of the phenomenon that Sellers challenged us to see. But chefs do this with food, not just with drink, challenging each other to do this. Okay, that's all I have to say about that. So we can, in our metavocabulary for representing reason relations, once we've satisfied ourselves that incompatibility is, and by rights ought to be, symmetric, say Ryan Simonelli's argument has convinced us, then we can represent the incompatibilities as just a set of incoherent sentences. So partition the power set of the language, the set of all the subsets of the language, into the ones that are incoherent and the ones that are coherent, and read the incompatibilities off of that. The claim is to say that gamma is incompatible with A, gamma hashtag hash mark A is just to say that gamma union A is an incoherent set. That builds in the symmetry. Now, this is the way the tradition, since Gensen anyway, has represented incompatibility inside the consequence relation. They code it inside the consequence relation. So Gensen marks a premise set gamma as incoherent by writing gamma turnstile and then an empty right side. And then we'll use that to define negation in the sort of way that we, or interpret negation anyway, in the sort of way that we will. Now, he also represents theoremhood by an empty side. To say that A is a theorem, he will write empty left side, turnstile A. You can get A from anything. Now, given monotonicity, which he assumes, if you can get A from nothing, then you can get it from anything. You can throw in more premises on the left-hand side, and that's the property of theoremhood that matters. If we're working in a non-closure structure, in an open structure, though, we can have the notion of a sentence that's a consequence of the empty set. When you look through the reason relations in the frame, the empty set's a perfectly good premise set. It may have things that are its consequences. But that notion of material theoremhood is of no interest whatsoever in a non-monotonic setting, because the empty set isn't special. The notion of theoremhood we want is following from everything, so following come what may. Whatever your premise set is, A is a consequence. If that's true, A has a very special status. And it might have one, even though it's not a logical theorem. That's what it is for it to be a consequence of everything. But the fact that it's a consequence of nothing doesn't mean that it follows from every premise set. So that notion of theoremhood is not interesting. If we follow this convention of representing incoherence by an empty right side, however, we're going to say that all the same structural principles that apply to consequence apply to incoherence. So for instance, if consequence is monotonic, so gamma is incoherent, that is gamma turnstile, the empty set holds, then for any delta, gamma delta will imply the empty set also. We'll be treating the empty right side just like any other conclusion. That is, we're building monotonicity into incompatibility. Whatever the structural principles are that we impose on consequence, they're going to be inherited by incompatibility, if that's the way we represent incompatibility. And that means that we're always going to be on the same level. If you think about that chart of degrees of monotonicity, implication and incompatibility will always have either satisfy CM or satisfy monotonicity. Either will both satisfy MO, or both satisfy CM, or both WCM. We can't mix and match and have incompatibility satisfy CM, whereas whereas implication is fully monotonic, and so on. So that's why I use two different turnstiles, because abstractly, the reason relations need not have matching structure in that way. Maybe there's an argument that they ought to, but they need not. Okay, this is just a sort of free-floating point. Is there a recipe for turning non-monotonic implications into non-monotonic incompatibilities? If you wanted to argue that the same structural principles ought to apply to both flavors of reason relations, this is the sort of thing you'd look for. Remember last time I talked about an argument that would turn examples of non-monotonic implications into failures of shared cut as a transitivity principle. Well, this is like that, except it's relating the two reason relations. I can't nail this down, but it seems to me that there ought to be a recipe for doing this. So if Tweety is a bird, then Tweety can fly. That's a good implication. Tweety is a bird then is, in the same sense, incompatible with Tweety can't fly. But Tweety's a bird and Tweety's a penguin isn't incompatible with Tweety can't fly. That's an example of non-monotonicity of incompatibility. Or the example I've given you here, Pearman's drinking a beer is incompatible with Pearman does not drink alcohol, but Pearman drinks a beer and the beer Pearman drinks is O'Doul's, a non-alcoholic beer is not incompatible. I'm using that little check mark to mark that it's not incompatible with Pierman does not drink alcohol. And in this case, Pierman drinks beer, and the beer Pierman drinks is O'Doul's, doesn't imply that Pierman doesn't drink alcohol. Maybe he drinks other kinds of alcohol, just not beer. I think the raw materials are here for an argument that if consequence or implication is non-monotonic, then incompatibility should be, and vice versa. Whether that's going to go through for CM and W and CT and WCM and WCT or not, I don't know. I just throw this example in so you can think about it if you like. Okay, and now I want to say something more about the interaction of these two kinds of reason relation. We're talking about rational inclusion and rational exclusion, implication and incompatibility. Seldom, I think, in the history of philosophy have they been given equal status. Mostly people have worried about implication, about consequence, and incompatibility, exclusion has been the poor stepchild. Hegel, I could try and make a case that he was even-handed his mediation and determinate negation, but the truth is he wants exclusion to do all the work. Negation is the metaphysical structure of the universe. I mentioned last time in the appendix to my Locke lectures, in between saying and doing, I take deriving consequence relations from incompatibility relations as far as I was able to do in a modal logic. We can do much better than that now. At this point, let me remind you that our pragmatic bilateralist way of understanding implication understands it in terms of a sort of exclusion. That is, Restall-Ripley bilateralism has two basic ideas. This is on the handout on page 4. That the two sides of the turnstile correspond to acceptance and rejection. They usually say assertion and denial. That's the bilateralism, literally two sides. That the left side, the premise side, is about what you accept, and the right side, the conclusion side, is about what you reject, what you deny. That's the bilateralism, but it's a normative pragmatic bilateralist understanding of the turnstile. It says to say that gamma implies A is to say that accepting all of gamma and rejecting A is out of bounds. That is, that doing that is incoherent, or that those are incompatible things to do. It's really using a notion of incoherence or incompatibility to define consequence. I mean, the notion Restall and Ripley use is being out of bounds, but it's just a division between inbounds and out of bounds, and being out of bounds is a kind of incoherence. Your position, if it's out of bounds, is an incoherent position. It's one you're not allowed to be in. So they're building in at a very deep level a connection between these kinds of reason relations. And that's one where wanting to be more even-handed, as I've been making such gestures, I specifically define incompatibility, as you'll remember, sort of on the model of the definition of implication, saying gamma is incompatible with A in case commitment to accept all of gamma precludes entitlement to accept A, which is implicitly committing yourself to reject it, remember, but explicitly, all it is precluding entitlement to accept. Well, that's saying that gamma together with A, you're precluded from entitlement to accept all of that. That is, that's an incoherent set. But it's important to me to put it in terms that are even-handed with implication, even though one of the basic ideas of bilateralism as a normative, pragmatic metavocabulary to understand implication, the reason relation, is to use out-of-boundness to define follows from. Okay, last 2 points I want to make about the interaction. One has to do with explosion. This is the principle ex falso quodlibet. From a contradiction, everything follows. This is a famous embarrassment when you teach baby logic of classical logic to explain how this could be remotely plausible. It's not something you get away from by moving over to intuitionist logic. It has ex falso quodlibet also. You do avoid explosion by going to relevance logic. That's one of the fallacies of relevance that it's designed to avoid. But the idea that if I contradict myself, then I've committed myself to everything. Very difficult to justify. When Hilbert believed all the Peano axioms, yes, every number has a successor and so on, and also believed that the Peano axioms were a consistent and complete axiomatization of arithmetic, well, then he believed a contradiction. That's Gödel's first incompleteness theorem. Was he in fact committed to everything? Just, for instance, did that commit him to the claim that sticking a knife through his hand wouldn't hurt? Not in any useful sense. Now, we're in a position to, so that explosion principle is for inconsistent premise sets. Should we have a principle like that? It's about the interaction of incompatibility or incoherence and implication. It says an incoherent premise set implies everything. Well, no, we wouldn't want to accept that as a general principle of material reasoning. It is actually going to be a principle of our logic that if your premise set explicitly contains any claim and its negation, then it implies everything. It only implicitly commits you to everything, mind you, but it does that. But I just wanted to point out here that the apparatus we've introduced shows a halfway point between classical explosion and simply saying that at least for many incoherent premise sets, we can still reason with them. in that there can still be a sharp distinction between what they imply and what they don't imply. So that we can say, well, actually, believing all the Peano axioms and believing that they provide a consistent and complete axiomatization of arithmetic, that does commit you to some stuff, but not to anything about what happens if you drive a knife through your hand. If we just look at abstractly specified reason relations, there's no reason to treat incoherent premise sets any differently in general than coherent ones. We often have incoherent beliefs and we need to be able to reason from them. In relevance logic, there is no difference you can see in the consequence relation between inconsistent sets and ones that aren't. No general global difference. But there is something to the thought that if you've got sufficiently incoherent beliefs, then you're cut off from reasoning, sort of anything goes at that point. It's so bad that you can't say some things follow and other things don't. But if we acknowledge that some implications are persistent and others aren't, when we gave up global monotonicity, we didn't claim there weren't any persistent implications. Some are, some aren't. Well, then among incoherent sets, we should distinguish between the ones that are persistently incoherent and the ones that aren't. The persistently incoherent ones are the ones that are incoherent, and so are all their supersets. No matter what else you throw into them, it stays incoherent. The principle that Ulf calls ex fixo falso quodlibet, EFFQ, says that persistently incoherent premise sets imply everything. If something is incoherent, but curably so, it's incoherent, but there are things you could add to it to make it coherent, then we can reason with it just the same as with anything else. It has some consequences. Other things are not consequences of it. Consult your material reason relations frame to see what it is. So we have two bits of apparatus for softening the blow of having incoherent beliefs. And one is we can accept only a modified version of explosion that applies to the persistently incoherent, the ones that are necessarily incoherent, as we say, they're incoherent come what may. And we say, yeah, those blow up inferentially, but ordinary common or garden variety incoherence is not. And the second one is we can say that there's a big difference between being committed to a premise set that implies something incompatible with that set, so that it has that incompatible claim as part of its implicit content, and actually being incoherent. That is, if we allow non-monotonic, non-persistent incompatibilities, so that at least some premise sets, though, if we look at the list of incoherent things, we find this is incoherent, but not all of its supersets are. When we look around in that region of the reason relations, we find it's sort of by itself. It's not part of an island of persistent incoherence. Then we can look at the effect of adding that incompatible consequence to the premise set and say, oh, well, now it's explicitly incoherent. But there's a difference between being implicitly incoherent and being explicitly incoherent. There's a difference between gamma being incoherent, in which case it's incompatible with with everything that it explicitly contains. That's different from having consequences, which when you explicate them, yield an incoherent set. So we can have coherent gamma that imply A, where A together with gamma is incoherent. We can have gamma that implies A and is also incompatible with A, in that if you explicitate A, you get an incoherent set. Then gamma is an explicitly coherent set that's implicitly incoherent. And of course, we can have the converse of that too. We can have explicitly incoherent sets that are not persistently incoherent. So there are some things you can add to them to make them to get a coherent set. And furthermore, it could be, this is the analog of CM for incompatibility, it could be that among the things that can cure the incoherence are some consequences of that very premise set. I mean, if we think about curable incompatibilities, in the context of classical mechanics, behaving like a particle and behaving like a wave were incompatible. But if you add to classical mechanics, quantum mechanics, now behaving like a wave and behaving like a particle can be compatible. That's a sort of garden variety curing of an incompatibility. That would be an instance of this stronger case if it turned out when we looked really hard at classical mechanics, it implied quantum mechanics. That's the case we're talking about here. But the thought, the sort of last substantive thought I wanted to leave you with is, this is a potentially philosophically significant category of sets of commitments that we've got, that there can be a set of claimables such that accepting all of them is not incoherent, according to our reason relations, but it has some consequences such that if you make those bits of its implicit content explicit, you get an explicitly incoherent set. If you think classically, that's an inconceivable situation. It's not here. I might write a book where what I'm explicitly committed to accepting is every sentence that's in the book. And the book might be perfectly coherent. And yet, it might have consequences, things that genuinely follow from that premise set, which, if you added them as an explicit appendix, would result in something that was explicitly incoherent, because what you'd added was incompatible with what you'd said before. Indeed, I suspect that I've written books like that. It's the job of the reader, the reviewer, and really, this is the defining job of referee number 2, to find those things, to find the consequence of the perfectly coherent article that you sent in, this set of sentences. No problem with it. It is coherent. But it's not persistently coherent. And it's not even, and it's implicitly incoherent in that it has consequences, which when they are made explicit and added to it, is explicitly incoherent. And as I say, things can go around, that can go the other way around, where you've got an explicitly incoherent set of premises, but that has consequences which, when you add it, cures the incoherence and yields a coherent set. So these are abstract possibilities that we can characterize in the metavocabulary of reason relations that I've put on the table. Reason can be like this, according to this metavocabulary for talking about reasons. Now, look, you might think that this is a bridge too far, and that what I've been doing today has been making explicit what's implicit in giving up the closure structure of reason relations. I've said, look, you can do it in stages. There's more and less radical ways of giving up the closure structure, the traditional Tarski-Gensen structure of reason relations. And there's interactions among them. You can give up these different bits. And all sorts of intriguing possibilities come up. I talked about the hysteresis of rational explicitation. Now I'm talking about explicitation turning coherent premise sets into incoherent ones, and turning incoherent ones into coherent ones. And at this point, you might think, well, so much the worse for the possibilities you're describing. These things don't make any sense. We're never going to be able to think consecutively and clearly about these cockamamie possibilities that you claim reason relations make intelligible. We'll never get a formal grip on these things. There's a reason that logic presupposes, classical intuitionist logic presupposes the closure structure, and you've really done a reductio on the possibility of relaxing those, of opening up the closure structures, because the stuff you're saying doesn't make any sense. Well, starting next week, I'm going to show you how logic can work on structures of reason relations that are radically substructural, that have nothing but CO holding in them, no stronger monotonicity principle, and no transitive principle of transitivity at all globally. They'll have regions where some implications and incompatibilities have these properties, to be sure, but we don't need to impose these global restrictions on the sets of reason relations that we can express in logical terms, that we can codify these reason relations in perfectly functional logics, indeed logics that look very familiar. The tweaks that we have to make in order to handle these radically substructural reason relations are actually pretty minor, as Dan Kaplan has shown. What looks like the Wild West, it turns out, can be tamed with formal tools that are readily constructible from the ones that we already had. And after looking at using logic to characterize these, then we'll look at semantics for them. Can we specify the roles that sentences play, their conceptual roles in virtue of being premises and conclusions in sets of reason relations that are radically substructural, that have a radically open structure? And we'll find, yes, we can. The implication space semantics is fine with radically substructural reason relations and gives us perfectly tractable meanings, inferential roles to go with sentences. And then Ulf will show us how to map that semantics onto Kit Fine's truthmaker semantics to see how it relates to a representational semantics first approach to meaning, which Fine only considers in a fully structural sense. We'll see what condition on the truthmaker apparatus corresponds to monotonicity and transitivity and so on. And Ulf's mapping of that back and forth onto the implication space semantics will show us how we can go substructural even in the truthmaker framework. So what I'm promising, the promissory note that I'm issuing, is this complex topography of open structured reason relations, of ones that have no monotonicity principles beyond CO, no transitivity principles globally, and mix and match various levels of it for particular reason relations within a whole frame of implications and incompatibilities. All of that, we're going to be able to introduce a pretty plain vanilla logic to let us say in the language what follows from what and what's incompatible with it. And we'll be able to do, to produce a very tractable semantics for manipulating these meanings. So that's where we're going in, well, really the next 4 weeks. Try and do the logic in the 2 weeks and the semantics in another 2 weeks. And one of the bonuses of the logic that I already mentioned in passing is, in addition to being able to codify implication and incompatibility using conditionals and negation, we can also introduce modal operators to capture local regions of persistence of implication and incompatibility, and indeed other local structural properties that don't hold globally, so that we can say of particular implications and incompatibilities that they hold persistently or that they don't. So in giving up global structure, we don't give up local regions of structure, but part of the expressive job of logic is not just to express the holding and not holding of the reason relations, but also to let us talk about these local regions that are more tightly structured. So that's what's on offer for next time. All right, well, I will see you then.